In this video, we're going to talk about a few proofs with coordinates. In particular, proving some things about triangles and quadrilaterals when they're on a coordinate grid. We've already talked about how to prove a point is on a circle or a line or any equation by just plugging it in and seeing if it works. So now we're going to get into a few other coordinate proofs. Here are some helpful tools. The distance formula, or Pythagorean Theorem, they're basically the same thing, can find the lengths of a segment, the slopes, to find how sloped a segment is, and then the midpoint formula, to find the middle point of a segment. So these might help us as we're working on a coordinate grid. I just wanted to point out, we use a lot of tools in our lives. For example, if I wanted to find my temperature, I could use a thermometer, or to find my weight, I could use a scale, or to find my height, I could use a lot of things like a tape measure or a ruler or a yardstick. However, a coordinate grid is helpful because I don't have to use tools like that. For example, if I have a segment that goes from -2, 0 to 1, 2, I could go get a ruler or something and measure this, but I don't have to because I have other tools like the distance formula or Pythagorean Theorem, which will allow me to solve for this length without even having to go measure it. So, coordinates are pretty helpful in that way. Just as a reminder, here is the distance formula. Basically, you just subtract the x's and square it, subtract the y's and square root it. That tells you the distance from one point to another. Or you could also just make a right triangle out of it and do Pythagorean Theorem to find a length. Slope, as you should be familiar with, is rise over run. It's the change in y over the change in x. It's y2 minus y1 over x2 minus x1. To find slopes is handy because if I can prove that two lines have the same slope, that means they're parallel. And if two lines have opposite reciprocal slopes, it means they're perpendicular. For example, this one right here has a slope of up 4 over 6, which is 2/3. If I wanted to be parallel or perpendicular to this line, I would need to flip it, so the reciprocal, and it would have to be negative, the opposite. Basically, if one's going up, this one would have to come down. And if this one's 2/3, this one would be 3/2. And then we also have the midpoint formula if you ever want to find the middle point of a segment. So with these tools in mind, let's go through a few examples here. So imagine I have triangle ABC that has these coordinates. I'm going to graph them. So -2, 3, that's A. 2, -1 is C, and -5, -4 is B. So here's my triangle. Ooh, goodness. Did I do that right? Okay. I want to prove that it's an isosceles triangle. As a reminder, an isosceles triangle has two congruent sides. If it has no congruent sides, it's called scaling, and if all the sides are congruent, it's called equilateral. I want to prove that two of these sides, but not three, are the same length. So again, I could go get a ruler and measure, but I don't have to do that because it's on a coordinate grid and I can just do some calculations. So, it looks like it's probably going to be these two that are the same, but we'll want to check that one just to be sure, because sometimes my pictures aren't the most accurate. So if I want to find the length from A to B, I could do Pythagorean Theorem or just do the distance formula. I'll subtract the two x's, -5 minus -2, square it, and subtract the two y's, so -4 minus 3, and square it, which ends up being, I'm gonna put all that in my calculator, -5 plus 2 squared. It ends up being the square root of 58. That doesn't come out even, so I'm just going to leave it as square root of 58, but you can make it a decimal if you want. Okay, so this right here is the square root of 58. Let's see if this one's the same. So again, I'm just going to do the distance formula for BC. So do x minus x, -5 minus 2 squared, and then y minus y, -4 minus -1. And when you type all that in your calculator, you also get the square root of 58. So, I think it is isosceles. However, I don't want this one to be the same, because if this one's the same as those, then it would be equilateral, not isosceles. So let's check and make sure AC is not also the square root of 58. This time, instead of doing distance formula, I'm going to show you Pythagorean Theorem. So if you wanted to find this length, another way to do it is to make a right triangle out of it and do Pythagorean Theorem. So to find AC here, I'll just do 1, 2, 3. This is 4, and this is 4. So I know that AC squared equals 4 squared plus 4 squared, which is 16 plus 16, so 32, and then square root. So the length of AC is square root of 32, which is not the same. So that proves that it's isosceles because AB was congruent to segment BC. And that's my proof. These calculations are my proof. All right, so that's triangles. Let's get into quadrilaterals a little bit. I just want to remind you of these definitions. So a parallelogram, by definition, is just parallel sides. These two opposite sides are parallel, and these two opposite sides are parallel. That's a parallelogram. So to prove that something's a parallelogram on a coordinate grid, you need to find these slopes and show they're the same, and then find these two slopes and show they're the same, and that's it. A rectangle, rhombus, and square are all parallelograms. So they're going to have parallel sides, but also a rectangle has all congruent angles, and a rhombus has all congruent sides. And then a square is a combo of both of those. So for a rectangle, if all the angles are congruent, they all are 90 degrees. Rectangle is like right angle. And so if you want to prove that this is 90 degrees, you're going to have to show that these two sides are perpendicular. And to do that is like we talked about before with the slopes. You got to show that the slopes are opposite reciprocals. Like if this one had a slope of 1/2, this one would need to have a slope of -2/1. Okay, for a rhombus, it's pretty similar to the triangle stuff we just did. If you want all congruent sides, you got to find the length of all 4 sides and show that all those lengths are the same. And a square, you would have to do all of those things. A trapezoid is only one pair of parallel sides. So again, that would be slopes. Find the slope here and the slope here and show they're the same. And then a kite is not as common, but a kite is just 2 pairs of congruent sides that are next to each other. We call that adjacent. So like these two are the same and these two are the same. Once again, that would just be find the lengths and prove that these two are the same and that these two are the same. You can also prove each of these by using their diagonals. So with parallelograms, the diagonals bisect each other. Like these cut each other in half perfectly. The way you could prove this is actually with midpoints. Find the midpoint of AC, and then find the midpoint of BD, and if they're the same midpoint, then the diagonals do bisect each other. With a rectangle, the diagonals are perfectly congruent. Like these lengths are exactly the same. That's not the case with any parallelogram. See how this blue one's way shorter than the red one? But with a rectangle, they are congruent. You would prove that by just finding this length and find this length and show they're the same. With a rhombus, it kind of makes this kite shape. And these look like kind of the bars of the kite. With a rhombus, the diagonals are perpendicular. They make a right angle. This is one, again, where you'll need to find the slopes and show their opposite reciprocals, because that's how you form a right angle. And then once again, a square is all of the above. It has to be all of those things.